Okay, we are in chapter 11. We are just going to focus on simplifying rational expressions, just one section in the chapter. And so, what is a rational expression? A rational expression is an algebraic fraction whose numerator and denominator are polynomials. Since division by zero is undefined, the polynomial in the denominator cannot be zero. All we're saying is make sure the denominator can't be zero, which you're not going to really run into that. To find the blank values of a rational expression, determine the values of the variables for which the denominator equals zero. So find the domain values. Okay, we don't need to find them. I can ignore the term excluded values. All I want you to focus on right now is how can I simplify these? So example 1, okay, we're not going to state the excluded values. We're just going to skip over this for the moment. Example 2, okay, we're just going to simplify these rational expressions. So the first polynomial on top, we have 15 and we have 40. Can we reduce this? This was kind of like chapter 7. Don't mind the paint all over my hand, sorry. Okay, we can divide 5 from both, and we're going to get 3 over 8. 4 minus 3 is 1. It's bigger on the bottom, so we're going to keep it on the bottom. 3 minus 2 is 1. So that's your answer. Here, they want you to multiply across. So we can multiply across and get negative 42, but I can see that 7 goes into 21 3 times. And so I have 2 C's, I have 3 C's, so I have 5 C's, I have a negative 6, and I have 3 on the bottom, and I have 4 C's on the bottom. When I reduce that, I get a negative 2 C to the first. Here, I get, well, I can see here that I can simplify the 3's. So we're going to keep that as a negative 1. We're going to divide by 3 here and make it a 3. So negative 4, because negative 1 times 4 is negative 4. And then we have 1, 2, 3, 4, 5, 6, 7 x's and 6 x's on the bottom. When I subtract, I'm still going to get negative 4x over 3. And here, 28 and 16, they both can be divided in 2. And so then that way we will get a 14 and an 8. But they could be divided as well. We'll get to that in a moment. There's 1a on top, 2 on the bottom, so we'll keep it on the bottom. 2 minus 1 is 1. 3 on the top, 1 on the bottom. 3 minus 1 is 2. But like I said, we can reduce this in half again. 7 over 4, b squared a. Okay, those were easier. That was like chapter 7 that we did. On the back is more like chapter 8. What happens when we don't have just, these are called factors, where there's everything's being multiplied together. These are factors. On the back, these are terms where we're adding and subtracting. So we have to factor them. We have to make them into factors using GCFs or just factoring a trinomial. So here we see that we have a GCF of 4. So if I take a 4 out, I'm left with x minus 6. And then on the bottom, do we have 3 terms with a plus in the back? Yes, so it's going to be x minus 6, x minus 6. Okay, so this is what that's going to turn into. What can we simplify that's on the top and the bottom? The x minus 6. So our final answer is 4 over x minus 6. So you can use the same procedure to simplify rational expressions in which the numerator and denominator are polynomials. First, factor the numerator and denominator if possible, and then divide by any common factors. So here we see this there a GCF on the top. Yep, a 2 and a p. When I take that out, I'm left with p minus 7. Go back and distribute to see if you did it right. Yep. And then on the bottom, is there a GCF? No. But I notice it's the difference of 2 perfect squares. What is the factor they share in common? A p minus 7. Anything divided by itself is 1, so we're just left with a 2p over p plus 7. Here, is there any GCFs? There is. There's a 2, so I'm going to take the 2 out. And on the bottom, there's not a GCF, but once again, it's the difference of 2 perfect squares. The square root of 25 is 5. One's positive, one's negative, for x times x. So is anything in common? Kind of, but not. So here, these would be the same. I want a positive x minus 5. So I wonder if I could take a negative 1 out of here. If I remove a negative 1 out of here, I could do 2x minus 5. Okay, or if I made this a negative 2, that would be a negative x, and this would be a positive 5. So 5 minus x, oh look, a negative x, a positive 5, a positive 5. Negative 2 over 5 plus x. Okay, and over here, there's no GCFs. But we can factor the trinomial, just like we did up here. Do I have 3 terms with a plus in the back? Yes, so this sign will appear twice. Do I have 3 terms with a plus in the back? No, so they're going to be different. All right, factors of 14 that give me 9, 2 times 7. And factors of 35 that give me negative 2 is 7 times 5. The bigger number is going to get the negative. And also, you're probably going to have the same thing on the top and the bottom. That's how you know. So anything divided by itself is 1. We're left with x plus 5 over x minus 2. Okay, on the bottom, there is no GCF. Oh, there is a GCF. There's an x. So x squared plus 5x minus 6 all over difference of two perfect squares, x plus 6, x minus 6. X. Do we have 3 terms with a plus in the back? Nope. Okay, factors of 6 are going to be 6 and 1 to get the 5. So one's positive, one's negative. We want the 6 to be positive, the 1 to be negative. These are going to simplify, and you're left with x minus 1, x minus 6. Here you have to ask yourself if there's any GCFs, and there's not. Okay. Remember, it's going to be a lot more complicated. So to factor the top, you're going to have 3 times 4, which is 12. What are factors of 12? That give you 8, 6, and 2. So 3x squared plus 6x plus 2x plus 4. We take a GCF here. We take a GCF here. We're left with 3x plus 2 times x plus 2. The bottom, you have to do the same thing. 4x squared plus 7x minus 2. 4 times negative 2 is negative 8. Factors of negative 8 that give you 7. A positive 8 minus 1. So 4x squared plus 8x minus 1x minus 2. We're going to take out a 4x. You're left with x plus 2. You want to take a negative 1 out. This is going to leave you with x plus 2. And a 4x minus 1. I'll give you a second because that was cut off and I didn't realize it. So these will simplify, and you're going to be left with a 3x plus 2 over 4x minus 1. The end. So it's incorporating all the factoring you've learned, GCFs, factoring a trinomial, and then just reducing.